In December 2007, at a small chemical plant in Florida, a massive explosion and fire killed 4 people, hospitalized 14, and spread debris up to a mile. Over 100 firefighters fought the hellish inferno. On February 16, 2007, a massive fire broke out at a refinery in Texas, leaving 3 workers seriously burned and 11 with minor injuries. In April 2010, an explosion on the drilling rig off the Louisiana coast killed 11 workers, injured 16 others, and caused a massive offshore oil spill in the Gulf of Mexico. You might wonder how this relates to you. These kinds of incidents can happen anywhere. It can impact operations, profitability, and most importantly, can impact your personal safety. Hence, there is a need for you to understand how you should not consciously or subconsciously contribute to a potentially serious incident. Process safety is important to preventing these types of serious incidents in your workplace. This course will describe process safety and your role and responsibility for its success. The goal of this course is to keep process safety concepts and processes at the forefront of every employee's and contractor's mind in the quest for operational excellence. The first section, Rationale for Process Safety, describes what it is, why it's important, the benefits of process safety, and how leadership commitment is critical to its success. In the next section, we will discuss 3 major components of process safety: technology, facilities, and personnel. We will also discuss the 14 elements of process safety that ensure all safety facets are considered for every process. In the next section, What can you do? Your responsibilities regarding process safety and what it means to maintain operational discipline will be explained. In the last section, we'll explore what happened in the refinery fire, what process safety standards were not applied, and how the incident could have been prevented in the first place. At the conclusion of this course, you will be able to define process safety, recognize its significance, describe the components of the process, and identify employee and contractor roles and responsibilities for its success.
Before we move forward, take this opportunity to review the information we just covered. Take a few minutes to look at the content outline on the left side of the screen and select a topic for which you'd like a quick review. Select the forward arrow when you're ready to continue.
Process Safety Management, or PSM, is the application of management systems and controls, such as programs, procedures, audits, or evaluations, to a manufacturing process in a way that process hazards are identified, understood, and controlled, so that process-related injuries and incidents are prevented. Process safety is crucial to preventing serious incidents where you work, and that means a safer community where you and your family live. Companies should embrace values that guide all levels of their business. Safety should be a way of life, and we are all personally responsible for our own safety and the safety of others. Process safety helps us control hazardous processes at work, ensuring that people and the environment are safe. Why is process safety important? Companies throughout the world are being held legally accountable for effects of process incidents. It's easy to see that employees, the public, property, and the environment are greatly affected by catastrophic incidents. Most process incidents can be traced to breakdowns in management systems or controls. By avoiding serious process incidents, property losses and business interruptions are reduced, and operational excellence is achieved. Process safety is good for business. Process safety helps improve productivity and reduce downtime, improve quality and customer satisfaction, protect our corporate reputation, and sustain our license to operate. Every company wants all work processes and systems to be safe. Process safety helps do that. We use process safety to identify and control process hazards at work, and to prevent serious incidents, death, and injury. It is expected that every employee and contractor be personally responsible for process safety. PSM aims to achieve operational excellence in safety by living out safety values, which are: all incidents can be prevented. Safety is a critical part of a company's culture. It's how business is done. Each employee is accountable for achieving results the right way, safely. This means all employees protect the safety and health of our team members and environment, as well as conduct our operations reliably and efficiently. Companies will only accomplish world-class performance when they consistently manage safety, health, environment, reliability, and efficiency within the organization. Process safety is achieved when each of us does our part with every task, doing the right thing the first time, every time. Let's take a closer look at the components of process safety.
It's time for a quick review. You'll have 2 chances to correctly answer the questions that follow, so take a look at the content outline and select the topic you want to review. Select the forward arrow when you're ready to continue.
Who is responsible for your safety and the safety of others? A. No one. B. Co-workers. C. Everyone. D. Management. Which of the following is a benefit of process safety? A. Reducing property losses and business interruptions. B. Weakening customer satisfaction. C. Increasing serious incidents. D. Increased downtime and reduced productivity. Consistently managing safety, health, environment, reliability, and efficiency within an organization will: A. Result in organizational bankruptcy. B. Result in massive employee terminations. C. Help accomplish world-class performance. D. Help sustain high employee turnover rates.
You passed. Good job.
Process safety applies systems and controls to a hazardous process to prevent process-related incidents. Process safety is an integrated systems approach comprised of 14 elements to ensure all facets of safety are considered for every process. Process safety has proven successful within many companies. The core of the model is management and leadership commitment, which supports the 3 main components: personnel, working with technology in our facilities to achieve excellence through operational discipline. Leadership and visible commitment from management is at the core of every successful process safety program. That means every manager, starting with senior management down through every level of the company, actively supports and reinforces the mindset of safety. The line organization must be committed to establish both organizational and individual safety objectives, and to assure facilities are operated within established policies, practices, and procedures. Site management plays an important role and is accountable to establish and sustain a safety culture, PSM expectations, accountabilities and objectives, resourcing, providing reward and recognition, and measuring performance. In addition, site management is responsible for demonstrating leadership, commitment, and personal involvement, designating a site PSM leader and PSM committee, and encouraging employee participation in safety activities, driving performance improvement by routinely reviewing and responding to the site program of leading and lagging indicators and performance metrics. All hazardous operations are classified as higher hazard process, HHP, and/or lower hazard operation, LHO. The classification is based on the consequences of unmitigated hazardous events relating to safety and human health effects, environmental impact, and property damage. A higher hazard process is any activity manufacturing, handling, storing, or using a hazardous substance that when released, ignited, or energy released, can result in death or major irreversible human health effects, significant property or environmental impact, or off-site impacts due to acute toxicity, flammability, corrosiveness, thermal instability, or reactivity. A lower hazard operation is any activity that exclusively manufactures, handles, stores, or uses any substances with a low potential for death or major human, property, or environmental impact, or off-site impacts due to toxicity, asphyxiation, or physical or mechanical hazards, including stored energy. For HHPs, all of the PSM requirements apply. For LHOs, the PSM requirements are less stringent. For example, in an LHO, there are no requirements for cyclical PHAs. The difference between HHPs and LHOs can be consequence-based or prescriptive-based. Prescriptive-based includes highly toxic materials, steam generation and related combustion, explosives, reactive hazards.
It's time for a quick review. You'll have 2 chances to correctly answer the questions that follow, so take a look at the content outline and select the topic you want to review. Select the forward arrow when you're ready to continue.
What does it mean that management is at the core of the process safety model? A. Management relies on frontline employees to handle issues regarding safety. B. Management is removed from the outer layers of operations that involve safety. C. Management must stay focused on bottom-line results, not safety. D. Management actively supports and reinforces the mindset of process safety. Any activity that exclusively manufactures, handles, stores, or uses any substance with a low potential for death or other human, property, or environmental impacts is called a higher hazard process, or HHP, B. Higher hazard operation, or HHO, C. Lower hazard operation, or LHO, D. Lower hazard process, or LHP.
You passed. Good job.
We've discussed the core of the PSM model, leadership and commitment. Next, we'll look at the three major PSM components: technology of the process, facilities to manufacture and handle the hazardous material, and personnel who operate, maintain, and support the process. These three components include the 14 elements needed to manage process-related hazards. The technology component of PSM addresses four areas: process technology, or PT, process hazards analysis, or PHA, management of change technology, or MOCT, or MOCT, operating procedures and safe work practices, or OP and SWP. The Process Technology Package, formerly called Process Safety Information, provides a description of the operation or process. It provides the foundation for identifying and understanding the hazards involved. This is the first step in the PSM effort. The PT package consists of four parts: hazards of the process, process design basis, equipment design basis, identification of PSM critical equipment. Process hazards analysis is used to identify, evaluate, and develop methods to control significant hazards. These hazards generally represent the potential for fires, explosions, chemical reactivity, and/or release of toxic materials. PHAs use an organized, methodical study approach, seek to achieve a multidisciplinary consensus on hazard identification and control, and document results for future follow-up, emergency planning, and training involved in operating and maintaining the operation. The operating procedures provide a clear understanding of and instructions on the detailed operating parameters and limits for safe operation. It also explains the safety, health, and environmental consequences of operation outside process limits and describes specific steps to be taken to correct and/or avoid deviations. Safe work practices provide a carefully planned system of procedures and permits involving checks and authorizations prior to performing non-routine work in process area for site and contractor personnel. Examples include open flames, confined space entry, and safeguarding hazardous energy sources, just to name a few. All changes to the documented process technology are subject to the same rigorous safety review as new processes. The change may require a complete PHA or subset of a PHA. Changes include new or modified equipment installations or configurations, changes to the design basis for existing equipment, changes in process materials or operating parameters, tests of new materials of constructions, process control changes, and modifications that impact or alter existing protective systems. The purpose of the facilities component is to ensure that integrity is maintained of assets with a high degree of rigor and quality throughout the design, build, commission, and operate phases. Process safety applies to new capital projects as well as existing operations. The facilities component has four elements: quality assurance, pre-startup safety review, mechanical integrity, and management of change facilities. Quality assurance bridges the gap between design specifications and the initial installation and includes the selection of suppliers and installers of process equipment. QA helps verify that process equipment meets the following standards. 1. Fabricated in accordance with design specifications. 2. Shipped and delivered to the proper location in good condition. 3. Stored, assembled, and installed properly on site. Pre-startup safety reviews, or PSSR, provide a final check of new and modified equipment to confirm that all appropriate elements of process safety satisfactorily addressed and the facility is safe to start up. Mechanical integrity, or MI, focuses on maintaining and continuously improving a system's integrity to contain hazardous substances and energies throughout the life of the facility. MI has the following features: 1. Maintenance procedures. 2. Training and performance. 3. Quality control procedures. 4. Equipment inspections and tests. 5. Repairs and changes. 6. Reliability engineering analysis. 7. Equipment budgetary processes. Management of change facilities addresses subtle or minor changes to process equipment and facilities. All changes, including those within the documented technology that are not replacement in kind, as well as temporary in-service repairs, that are actually changes that should go through appropriate review and authorization. Some examples of facility changes that are subtle or minor are rerouting a piping system and temporary leak repairs and patches, just to name a few. The personnel component ensures that personnel have the skills, competency, knowledge, and operational discipline necessary to operate the facilities and technology. This includes ensuring that personnel have good process safety knowledge at all levels of the organization. The personnel component includes 6 elements: personnel training and performance, contractor safety and performance, incident investigation, management of change personnel, emergency planning and response, and auditing. Site-specific training programs are an essential element of PSM throughout each segment of the manufacturing organization. All other elements of PSM can be in place, but without personnel who are knowledgeable and dedicated to consistently following documented policies, and the chances of maintaining safe conditions and preventing incidents is significantly diminished. It is also essential that employees be physically able, mentally alert, and capable of using good judgment to properly follow prescribed practices. The key components of personal training and performance are basic and refresher training, job task training, fitness of duty, dealing with diminished capacity, and fatigue risk management system. Whether completed by site employees or by contract employees, it is essential that all tasks involving high hazard processes and PSM critical equipment be completed safely in accordance with established procedures and/or safe work practices, and be consistent with the principles and essential features of PSM. Examples of some key essential features of contractor safety and performance include evaluation of contractor safety performance as part of the selection process, establishing clear lines of communication, informing contractor of known hazards, informing contractor of safety rules and procedures, periodical evaluation of contractor performance. Process-related incidents, including near misses, may recur unless key factors are identified and corrected. Thorough and persistent reporting and investigation of process-related and near-miss incidents, coupled with actions directed at prevention of recurrence, continually improve process safety. All incidents are reported and investigated, including near misses. Root causes are determined, recommendations are developed, and corrective actions taken. The management of change personnel element is an essential ingredient that is interwoven through all of the elements of PSM because it relates to people. It is important to maintain a minimum level of specific direct process experience and knowledge and skill in managing process safety within the site line and support organizations. Loss of minimum levels of experience and knowledge through personnel movements and organizational change, like changes to technology or facilities, potentially invalidates prior hazard assessments. Essential features of management of change personnel handled by sites are to develop and implement criteria and guidelines regarding MOCP, Ensure minimum levels of specific, direct process experience are maintained. Ensure minimum levels of staffing, knowledge, and skill are maintained in vital PSM roles. Access to external support, including contractors and consultants, can also be considered. Emergency planning and response for potential emergencies is essential for an effective response by site personnel, working in close conjunction with supporting community emergency response organizations. The result of emergency planning is mitigation of the impact on personnel, environment, and facilities, and prompt control of the emergency. Essential features of emergency planning and response are a written response plan based on hazards and consequence, a plan that addresses a range of releases from small to large, training for site personnel based on their role, emergency response drills. Auditing is a key tool in the establishment, measurement, maintenance, and continuous improvement of process safety performance. Audits compare performance against established standards. Proper auditing provides a process that reinforces correct systems, behaviors, and work practices, while identifying opportunities for improvement. Active participation by site personnel throughout the line management, with appropriate technical expertise and experience, is also important.
It's time for a quick review. You'll have 2 chances to correctly answer the questions that follow, so take a look at the content outline and select the topic you want to review. Select the forward arrow when you're ready to continue.
Which element of the technology component of the process safety model provides a description of the process or operation? A. Process technology, PT. B. Process hazards analysis, PHA. C. Management of change technology, MOCT. D. Operating procedures and safe work practices, OP and SWP. Pre-startup safety reviews, PSSR. A. Bridge the gap between design specifications and initial installation. B. Maintain and continuously improves a system's integrity. C. Provide a final check of new and modified equipment. D. Addresses subtle or minor changes to process equipment and facilities. Which element of the people component of the process safety model is directed at preventing a recurrence of a real or near-miss incident? A. Auditing. B. Contractor safety. C. Incident investigation. D. Management of change personnel.
You passed. Good job.
We believe that all injuries and occupational illnesses, as well as safety and environmental incidents, are preventable, and our goal for all of them is zero. We will promote off-the-job safety for our employees. We will assess the environmental impact for each facility we propose to construct or acquire, and will design, build, operate, and maintain all of our facilities and transportation equipment so they are safe, secure, and acceptable to local communities, and protect the environment. We will be prepared for emergencies and will provide leadership to assist our local communities to improve their emergency preparedness. Compliance with this commitment and applicable laws is the responsibility of every employee and contractor acting on our behalf, and a condition of their employment or contract. Management in each business is responsible to educate, train, and motivate employees to understand and comply with this commitment and applicable laws. As an employee or contractor involved in hazardous operations, you are responsible for the following. Make sure you have skill and knowledge in the process, including specific environmental, health, and safety hazards. Attend training related to your job's hazardous process. Follow operating procedures and safe work practices applicable to your tasks. Know emergency procedures, including how to safely and promptly shut down operations to a stable condition. Evacuate your work area. Account for all personnel, including emergency responders. Obtain first aid assistance. Notify potentially affected parties. Coordinate with site and local emergency response groups. Be prepared to respond in an emergency. Know the emergency procedures specific to your work assignment and how you should respond. Make sure you know what alarm signals require action on your part. Know how to report an actual or potential emergency situation and your reporting responsibilities. Know the evacuation routes from your work location to safe assembly points. Make sure you can properly use any personal protective equipment needed. Participate in emergency response drills or training. Participate in incident investigations as needed, whether as a witness or as a member of the investigation team. Immediately report to your supervisor any actual or potential process safety issues, such as leaks, spills, releases, mechanical integrity problems, or any other issue that could potentially lead to any type of process safety incident. Be involved, as needed, in audits, pre-startup safety reviews, quality control reviews, or other process safety activities. Maintain operational discipline. That means you carry out each task the right way every time. When you perform any task, make sure to conform with process safety standards. Be consistent in practice of procedures. Follow up-to-date documentation, such as procedures or records. Avoid shortcuts or workarounds. Maintain excellent housekeeping. Apply lessons learned from previous incidents. Communicate with others as needed. To encourage operational discipline, the company should provide sufficient resources to support safety programs, require employee involvement, advocate strong teamwork and networks, promote common shared values, conduct safety audits. A well-managed process safety system results in a clean, safe, and reliable operation, and together with operational discipline, leads to operational excellence.
It's time for a quick review. You'll have 2 chances to correctly answer the questions that follow, so take a look at the content outline and select the topic you want to review. Select the forward arrow when you're ready to continue.
One process safety responsibility for all employees is to A. Ignore requests to participate in audits, PSSRs, and quality control reviews. B. Know evacuation routes and procedures for your facility. C. Hone responsibility for safety on yourself only. Let others worry about their own safety. D. Only attend after-hour training sessions. What is meant by operational discipline? A. Carrying out each task the right way every time. B. Ensuring you are informed on how to operate every piece of equipment, regardless of whether or not you actually work on it. C. Executing shortcuts to improve productivity levels. D. Ignore process safety standards and protocols.
You passed. Good job.
Let's take a closer look at the fire incident we saw earlier in the course. The massive fire broke out at the propane deasphalting unit, leaving 3 workers burned and 11 with minor injuries. The fire shut down operations for 2 months, reduced operations for nearly a year, caused direct losses of some $50 million, and caused temporary shortfalls in the gas supply. Here's what most likely happened. High-pressure liquid propane used to separate asphalt and gas oil flowed through a control station up to an extraction tower. Originally, there were 2 control stations, but in the early 1990s, one of them was closed off using several valves, creating a dead leg or unused piping. At some point, a foreign object, a piece of metal, wedged under one of the valves, leaving a path for liquid to seep past. Small amounts of water from the propane sank through the valve, accumulating in the pipe elbow below. In February, a cold snap caused the water to freeze and crack the elbow. When the ice began to thaw, propane escaped through the cracked pipe. A large flammable vapor cloud formed, was windblown to a boiler house, and ignited. Flames flashed back to the cracked pipe, forming a high-pressure jet fire. Nearby pipes were quickly damaged, causing a second jet fire, aimed at a non-fireproof steel support structure. In minutes, the steel structure collapsed, breaking open many lines of flammable material and spreading the fire. Emergency responders could not turn on stationary fire water monitors due to shifting winds. Within 15 minutes, the refinery was evacuated. Could this fire have been prevented? Investigators think so. Let's look at the process safety elements that were compromised. The incident began in a dead leg or unused piping. A management of change review was not conducted to safely remove the piping from service. Freeze protection of piping could have prevented the incident, but the company had no formal plan in place. A failure in process hazard analysis. First responders were not able to reach shutoff valves due to the fire. The company's process hazard analysis called for remotely operated shutoff valves, which were never installed into the deasphalting unit. A breakdown in operating discipline ended in disaster. A non-fireproofed support structure gave way in the fire's heat. A failure in process hazard analysis. 2 near misses were identified due to failures in process hazard analysis. Toxic chlorine gas was released into the air when the intense heat melted the plugs on 3 large containers of chlorine stored near the de-asphalt unit. Fortunately, all responders had been evacuated beforehand. One of the 4 large tanks filled with liquefied petroleum gas was exposed to heat from the fire, its paint blistering. The tank could not be cooled since the valve to turn on the water deluge system was too close to the raging fire. What can we learn from process-related incidents like these is that everyone, management, employees, and contractors involved in hazardous processes, must be personally responsible for process safety. Process safety must be applied based on the hazard, not just to meet regulations. Catastrophic incidents happen around the world, in all types and sizes of industries, and they can happen here too, unless we take appropriate actions to prevent them. Everyone is accountable for process safety. What you do counts. Discipline yourself to work safely every time. Make sure you have the skills, competency, and knowledge you need to work safely. Adopt the process safety approach to your work here. Live safety every day. Working together, we can prevent catastrophic incidents and keep our families and community safe.
Before we move forward to the comprehensive test, take this opportunity to review the main points covered in this course. Select the chapter you'd like to review from the content outline on the left side of the screen. When you're ready to take the comprehensive test, select the Test button.
Process safety helps control A. The use of personal protective equipment. B. The number of hours worked by regular full-time employees. C. How many sick days are processed in a given area. D. Hazardous processes to keep people safe. One of the benefits of process safety is A. Eliminating license to operate. B. Avoiding serious incidents. C. Increasing customer dissatisfaction. D. Increased injury and incident rates. Consistently managing safety, health, environment, reliability, and efficiency within an organization will A. Result in organizational bankruptcy. B. Result in massive employee terminations. C. Help accomplish world-class performance. D. Help sustain high employee turnover rates. At the core of the process safety atom is A. Technology. B. Facilities. C. Management leadership and commitment. D. People. A lower hazard operation, or LHO, is A. Any activity with a known hazard. B. Any activity that when released, ignited, or energy released can cause death or major irreversible human health effects, just to name a few. C. Any operation involving flammable materials. D. Any activity that exclusively manufactures, handles, stores, or uses any substance with a low potential for death or other human, property, or environmental impacts. Which of the following element within the technology component is used to identify, evaluate, and control significant hazards? A. Management of Change Technology, MOCT. B. Process Hazards Analysis, PHA. C. Operating Procedures and Safe Work Practices, OP and SWP. D. Process Technology, PT. Which element of the facilities component bridges the gap between design specifications and initial installation? A. Pre-startup safety reviews, PSSR. B. Quality assurance, QA. C. Mechanical integrity, MI. D. Management of change, facilities. The people component of the process safety model, A. Ensures that personnel have the skills, competency, knowledge, and operational discipline necessary. B. Insists that everyone possess at least a 4-year bachelor's degree. C. Requires everyone to be at least 5 feet tall to operate in our facilities. D. Demands that everyone be on a first-name basis with each other. One process safety responsibility for all employees is to A. Ignore requests to participate in audits, PSSRs, and quality control reviews. B. Know evacuation routes and procedures for your facility. C. Hone responsibility for safety on yourself only. Let others worry about their own safety. D. Only attend after-hour training sessions. One way the company encourages operational discipline is to A. Emphasize consistent productivity over safety. B. Discourage teamwork to avoid distractions on the job. C. Offer overnight flex hours to those who want it. D. Provide sufficient resources to support safety programs.